Here is an explanation for the answer to final exam question number 82 in Trigonometry Demystified 2nd edition. Please refer to the top of page 385. And here is a variation, a mutation if you will, of figure exam-10, which applies to this question. We have this concave mirror again, just as we had in the previous question. And actually, I recommend that you go back and watch that video right now and then come back to this one. Watch the video for exam question number 81 now, and then come back here and watch this one. We have the mirror, we have the focal length concave mirror. Here's an object close to the mirror. It's 1.2 focal lengths away from the mirror, so we let the focal length represent 1 unit. And in our formula that relates these distances, which we learned about in the previous video, we have this equation. This gives us the distance to the image, which works out to be 6 focal lengths, because once again remembering that this ratio equals 5/6. So this will be 6 focal lengths away. This will initially be 1.2 focal lengths, like that. Now, the question here, number 82, says we start with this situation, just like we did in the previous problem. At this time, we move the object closer to the mirror instead of farther away. We cut this distance to only 0.6 times f. Well, let's go back to our original formula and see what happens when we plug the values in there. You can probably tell if you've had any optics courses that we're going to lose the image. It's going to vanish. But let's just work this out. R sub I, R sub O. 1 over the focal length equals 1 over the distance to the image, plus 1 over the distance to the object. Well, now we cut this right here to 0.6. 0.6 is, of course, 6/10. So what happens is this becomes 10 over 6. 1 over 6/10 is 10 over 6. This 1 over f, well again, f is 1 unit, so it's itself. We can say that's 6/6. Now 6/6 equals what? Plus 10/6. Oh, wait a minute. This is minus 4/6. That means the distance to the image is negative. But when we have a distance to the image that's negative, we might think, what does that mean? Does it mean it's on the other side of the mirror? Well, it can't be. The mirror is opaque. It reflects the light. Whenever we get an answer that's less than 0 for any of these distances or displacements, is what they actually are, it's undefined. So what's going to happen here is that this image, as we move this object closer and closer and closer to the focal point, this image is going to get farther and farther away over that way. When that object actually reaches the focal point, the image will go to infinity, and then if we move the object even closer yet, in a figurative sense, We might actually say that the image is farther away than infinity. But infinity is undefined enough. Farther away than infinity is sort of a mathematical overkill. In any case, the correct answer to this question is A. We cannot define the distance to the image because it will vanish.